welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, education lead at ZKM. Today I'm joined here with co-host Pavel, who is DevRel lead at ZKM, and our guest Scott, who's co-founder and CTO of Space and Time. Thank you so much for being here, Scott. We're very, very excited to have you.
I'm super happy to be here. Thanks for having me on.
Yeah, of course. Yes, it will be. I'm wondering, Scott, if we can first start off with a brief introduction of yourself. So your story on how you got into the Web3 and ZK spaces. And I know that you previously focused in your previous career on cloud solutions. So I'm wondering if you can also talk about that transition to Web3.
Absolutely. My co-founder Nate and I both spent a decade each at a publicly traded Fortune 500 data warehousing company called Teradata. We were building these big, half petabyte sized data warehouses for big American technology corporations like Blizzard Games, Southwest Airlines, JP Morgan Chase, kind of centralizing financial data and the internet's data into these big analytic black boxes that were kind of plagued the last 2 decades of this whole trend of stealing people's data from the internet and having them owned by corporations. So it's really exciting to be working in the decentralized space now, where we can kind of give a little bit of control and a little bit of data ownership back to the internet's constituents through blockchain. So it's a big change, kind of going from the dark side to the light side.
Yeah, I really like that transition as well, from centralized to putting this data into what you call black boxes, into something where it's transparent and also accessible to everyone, just basically transferring ownership back to all the constituents. I really like that vision. And just on that topic, I'm wondering how your vision for Space and Time has evolved, from when you first co-founded it to now, and how you see it fit into the broader ZK space.
Yeah, so much has changed. So we got together summer 2021. I had been looking at smart contracts and DeFi prior, during COVID. COVID hit, had a lot of free time, got super into crypto, looked at how Chainlink worked, how Aave worked, how Uniswap worked, and got super evangelized into debanking, bankless, let's use DeFi to change the world. And summer 2021, my co-founder and I got together, and we're coming from this data warehousing background, building big databases for the Fortune 500, and we're thinking, okay, why can't smart contracts access data on chain? We were shocked, and I think today most people don't even know this, that smart contracts in the EVM and in the SVM, they don't really have access to the chain's history. I can't write a smart contract that on chain asks basic questions about activity on chain. I can't answer a question as simple as, what's the total volume of transactions that Scott's wallet has paid off? It's such a simple question, but it can't be answered in Solidity. So my co-founder and I were thinking, okay, maybe the space needs a crypto native on-chain database that smart contracts can access to ask questions about historical information. We weren't thinking ZK would solve this day one. We were thinking maybe consensus would solve this, kind of more Oracle network style, where you have a bunch of redundant computations. And we realized pretty quickly, okay, that's not going to work. So we transitioned to using mathematical proofs. And I'm not even 100% sure at the time, summer 2021, we even called it ZK, or even knew at the time that it was zero knowledge proofs we were looking at. We just were hey, we need to mathematically prove that the data we're providing to smart contracts has not been tampered. And the compute, the SQL query execution, the processing of that data, the filters, the aggregations, the sorts, the find Scott's wallet and aggregate the total volume of his transactions, that needed to be cryptographically, mathematically proven for smart contracts like Aave to trust us. So long answer just to say, in the early days, we were just thinking math. We're hey, we got to solve this problem with math. We didn't know how dramatically the ZK industry would evolve over the following 3 years to what we have now, a term, for example, ZK coprocessor, that a lot of folks in the ZK space now understand. That was not a thing 3 years ago. So it's exciting to see this all come together.
Yeah, definitely, definitely. And just on that topic with our current limitations within smart contracts, like what you mentioned of we can't really, they can't really access historical information from there. I'm wondering, like for space and time specifically, what sort of data-driven questions can they ask to, say, like verify their activity?
Yeah, so without space and time or without ZK coprocessors that can provide this data, like all a smart contract on Solidity can really ask is like about the current transaction or about their own local storage. Like smart contracts can store a little bit of data in the smart contract. They have a little bit of storage slots and they can log some information. Like when I take a loan out with Aave, Aave's own smart contracts log how much I took out, what currencies, what wallet address, basic stuff. And of course, the smart contract can access that, basically access their own information, but no other broader information on chain. So space and time is basically just a database of every block, every transaction, every single smart contract event emitted, every storage slot update in this big database that is kind of a familiar Dune style data model. And client smart contracts, meaning DeFi protocols that want to be data driven, that want to build more sophisticated, more data driven DeFi on chain. They send the space and time contract a small payment along with a SQL query request. Next block, they get back their answer. So like when I go to take out a loan with a next generation lending protocol, I as a client would initiate the transaction, say, hey, I want to take out a loan. The DeFi protocol, the lending protocol, would then ask space and time, hey, show me the total volume of loans that Scott's wallet has already paid off. Next block, the space and time network returns back that answer, the volume of my loans I paid off. And if I've already paid off a bunch of loans, maybe I get a better borrow rate. Data-driven DeFi that we can enable with this kind of technology.
Yeah, definitely. And wondering just about the security and also the any like the trust side that's introduced with this. So I'm wondering if you could explain to the audience how these smart contracts can access also like off-chain data without having to introduce any kind of new trust assumptions.
Yeah, great question. So when you're accessing on-chain data, we're not introducing trust assumptions because that data is sort of already committed by the source chain. The source chain, Ethereum, zk Sync Era, Polygon, you name it, they already commit that data in blocks, and we can use those state roots or those kind of the raw chain signatures as a proof. Whereas off-chain data, we just need someone to sign it. So like we have a couple projects right now that are building on space and time that are sending TradFi market data. Like for example, stock prices from Bloomberg or from a bunch of different stock API providers. We just need the data to come from a signed source. So if any data is inserted into space and time and signed, then our chain can verify the signature, create the kind of cryptographic commitments we need for our ZK proofs in order to query that data later on chain, and then store all that. So now we kind of have tables that off-chain clients have inserted into that, and one of the columns in that table is like the wallet address of the person who inserted the data, the signature from the clients that inserted the data. So at least we know where the data came from. Now, whether you trust that off-chain source is completely up to you, right? Maybe it's an off-chain source that's like a Chainlink Oracle that collected centralized exchange price feeds from 10 different exchanges, aggregated them, came to consensus, signed that data, inserted it. We trust that. Or if it's, an insurance company building RWA insurance on chain, maybe like parametric insurance on chain, maybe they have a bunch of source weather data, like IoT sensors that sense the wind speeds in Florida, and they trust those sensors because that's their own sensors. So those sensors can sign the data, insert them into space and time, and then a smart contract can just query space and time and say, yo, what was the total aggregated average wind speed in Florida today? And if that wind speed is greater than 100, we call it a hurricane, and we pay out people on chain. As a dumb example, my point is like, you can trust the off-chain data if it's yours. You can't really trust it if it's someone else's and it's not proven. So off-chain data is kind of a tricky one, right? Like I think it kind of blurs the line between trustless and trust minimized.
Mm-hmm. Yeah, definitely. And can you also make that differentiation for anyone who's like not too familiar in the audience between trustlessness versus being trust minimized?
This is a philosophical question, but I have my own opinion. I'll just give you an opinion, right? Nothing more than that. I see trust minimized as a smaller group of nodes that come together either via consensus to prove some work they did. And I say smaller, I mean like, for example, 30 nodes or less, 40 nodes or less, 7 nodes, like a couple dozen nodes that either A, come to consensus, or B, have some kind of like restake security against them if you're thinking like eigenlayer AVSs, for example. Trust minimized because they're coming to as multiple parties agreeing to do something together in coordination. I think we as an industry use the word trustless when describing either A, ZK proofs, like actual mathematical cryptographic proofs that prove something, so you don't have to trust it at all. There's no trust assumptions. Or there's so many nodes redundantly doing the work, like Ethereum mainnet, where you have, maybe 4,000 active validators at any given time that are participating in that like epoch or something. I don't know, where there's just so many participants that it's mathematically secure. I'd say like, I hate to put numbers to it, but maybe 50 nodes or less is trust minimized. Maybe 50 to 10,000 is trustless. We'll see. But the point is, the most trustless, if there's a spectrum, would be ZK proofs, right? Because then you're not relying on a bunch of blockchain nodes redundantly doing computations and coming to consensus and worrying about like 2/3 attacks or 50% attacks, 51% attacks. You're relying on a mathematical proof to prove that that it's trustless. And I think the reason that folks like Vitalik and other industry leaders are so excited about ZK as the end game is because not only do you not have to trust all the validators of Ethereum, you just trust math. It's even better. It's like better than Ethereum.
Yeah, thank you for making that that distinction as well. I see like a lot of the times, a lot of projects are kind of interchanging trust minimization and also trustlessness. So really great that you're able to speak about that distinguishment over
Trust
there.
minimization is like enough security. It's like security.
Yeah, just enough. Yeah.
Yeah.
Right. And you mentioned a little bit about, like, for example, Vitalik's take on the ZK endgame. I'm wondering about what your take on it is, like what our world would look like when we reach that ZK endgame. And do you really think that ZK is the endgame, or are there some other, say, like cryptographic protocols that will also come into play in the future? Like right now we're hearing a lot about MPC, a lot about FEG, Ts coming into play. Do you think that we'll see kind of one of those protocols like ZK dominating, or perhaps like a combination of a few?
Yeah, really good questions. And you asked about 3 different questions, so I'm going to try to answer all 3 if I can. The first question you asked is like my opinion on ZK being the end game. Right now, we're already seeing optimistic rollups work with ZK VM providers like SP1 from Succinct and RiskZero to start to ZK prove their own blocks, because fraud proofs are challenging in that they rely on good Samaritans in the network to kind of be watchdogs for the network, and they're not super secure. I mean, like no one's saying fraud proofs are the end game, right? Like you don't hear that. Nothing wrong with them. They're just not like a great way to do L2 security. And so what we're already seeing is a lot of optimistic rollups begin to work with ZK teams to start to basically turn into ZK rollups, like turn optimism into a ZK rollup by having SP1 from Succinct prove the optimism blocks, which is awesome. The reason that's so important is because like the Ethereum scaling strategy requiring L2s also means that we need those L2s to prove to Ethereum what they did over the last epoch or the last checkpoint or the last hour, whatever it may be. Without some kind of mathematical proof of what they did, L2s aren't really decentralized. They're not really trustless, and therefore they're not really secure. So I think Vitalik sees this incredible opportunity to make all L2s mathematically secure with each rollup, proving what it does. And so I think we're going to see all rollups someday be ZK proven. And so teams like ZK Sync that are a little ahead of the curve are going to be in a good place in 2 years when like all technology moves towards ZK rollups. The second part of your question was like MPC, FHE, TEE. There's all these other exciting cryptographic advancements that are also hailed as like the holy grail of cryptography, but in different venues for different purposes. Zero knowledge proofs are about mathematically proving computations over source data, proving that some kind of transaction was executed, some kind of solidity opcode was executed, space and time, proving that we processed data and did a filter of the data correctly, proving that we aggregated it directly, we found the average price of Scott's wallet correctly, proving mathematically. ZK rollups need the ZK proof because they have to prove to Ethereum that they executed a set of transactions and correctly balanced the books. We have to prove to client contracts that we're not lying about the data. So when you start to get into other cryptographic primitives like FHE, fully homomorphic encryption, that's about hiding things. It's not about proving that you did a computation correctly. It's about hiding that computation altogether. Totally different use case, and it can be combined with ZK, and together you have the holy grail. I do see like the deep future of blockchain, call it hesitantly like 10 years out, like another generation of chain technology that combines FHE and ZK. FHE to hide the transactions and keep everything private from like government states, from bad actors, maybe even from validators themselves, like maybe private from the mempool to avoid MED. FHE to keep transactions private, ZK to prove that computations were done correctly on those transactions. Basically prove what the smart contracts do with ZK, use FHE to hide the transactions themselves. MPC, that's kind of like better ways to trust minimize. And TEEs are like a wonderful way to do computations kind of hidden and kind of trustlessly, where where it's like you're on your way to ZK, but you don't want to do it full ZK because that's too hard. So just go do it in a TE because that's like halfway there.
Yeah, I really love those comparisons and also like the interplay that you mentioned with FHE, that main goal to keep transactions private, and then ZK proving to prove that those computations were done. So really liked how you kind of mapped out those different scenarios.
And just to follow up with the different types of encryption and essentially hiding the data. How does I noticed that in the docs in the space and time documentation, you're able to execute certain queries on encrypted data. Can you go over how that would work and like what you use in the I guess to operate on that data?
Yeah. So encryption is interesting because we have like an encryption gateway that sits out front of the space and time network, where either A, clients can encrypt themselves on their own client device, like self-custody their encryption keys. We have a client SDK where clients, before inserting data into space and time, can sign and encrypt with their private key. So they're sending us signed, already encrypted data that they encrypted on a client device. We also have an API. We also have an encryption gateway where they can delegate encryption to space and time labs, like to a centralized gateway in front of the decentralized network that will do encryption and kind of custody keys for them as a convenience. So what's getting inserted into space and time, I say chain, but it's really just a bunch of tables managed by the chain, is tables of data that are already encrypted. And then we're running a ZK proof on those tables, and we're ZK proving that we did SQL computations on encrypted data correctly. So the proof is actually going to be against encrypted data. And when we return to the client device first validates the proof, like verifies the proof locally against encrypted data, and then uses their local private key to decrypt the actual query result. So they're kind of getting like an encrypted query result to be ZK proven and ZK verified, and they're getting a decrypted query result to actually, once they verified, actually see the raw data. Point is, they can encrypt and decrypt client side, and they can also sign and verify proofs client side. The reason this is goofy is like, that works great for like client devices. What about smart contracts? When our client is a smart contract, they can't hold private keys. Like smart contracts aren't able to encrypt things on chain because all transactions are public. You can't have a public encryption, you know. So it gets much more challenging when we want to do private things on Ethereum or private things on zk Sync Era. Privacy is more of an off-chain concept in terms of like delivering query results. Does that make sense? There will be, again, a new generation of chains that we're already seeing being implemented using FHE, using other encryption standards, and building privacy-oriented chains. You know, Phoenix, Aztec, that are that in that case, smart contracts could actually encrypt data and retrieve encrypted results on chain as well. That's exciting. That's an exciting future, but that is not the case on Ethereum.
Got it. But it's still good to see that off-chain operations can still be proven within the systems that you're creating within space and time, and then especially taking in the business cases of encrypted data and offering essentially that service to providers that might not want to have all forms of data exposed for that, but still want to
Yeah,
maybe
and a
leverage the
great
power.
example is like RWAs, American financial institutions or global financial institutions that want to mint RWAs on chain. Like they might not want all the details of their source database where they hold that RWA to be public, nor do they really want to know. They don't really want to make public like the their own brokerage accounts and who owns those RWAs and what financial institutions. They're fine with it being public once it's tokenized. But until it's actually minted as RWAs on chain, like there needs to be some privacy. So that we help with like bringing private off-chain financial market data on chain and then making it public to be minted as RWAs.
I like it. Good pathway for adoption. So very, very clear in that case.
Yeah. And just kind of summarize, space and time network as a service already collects data from Ethereum. It's already loaded with the entire history of Ethereum, the entire history of zk Sync Era, Polygon, etc. Our network does that natively. It goes and collects that raw data, comes to consensus that it witnessed that data correctly, threshold signs that data, and loads it into the provers to be proven to smart contracts. But off-chain clients, financial institutions, can load their own data from their own trusted sources, their own cloud databases that I built back in the day. They can load those into space and time with encryption and with like signed data from the source. But is that trustless? No, it's actually you're trusting the financial institution that's onboarding that set of data. Whereas Ethereum data is fully trustless end to end.
Yeah, got it. Thank you for that summary as well. Wondering if we could talk a little bit more about the topic of adoption and also more specifically about how you guys try to optimize for the developer experience. I'm wondering what kinds of challenges do you see currently existing for devs trying to build ZK related applications? What parts of the developer's journey are you trying to optimize for?
We care about this a lot. So we put a lot of engineering effort, a lot of investor dollars into improving the UX as much as we can. We built a really clean AI studio for allowing developers to just ask natural language questions about the chain, and then that generates SQL for them, and they can play around with it in sort of a sandbox where they're not getting charged a lot of like prover computation money while just like building their SQL queries. They can kind of build them in a sandbox that's cheap and efficient and AI powered to accelerate. And then once they've built the SQL queries that they know they need in production, the process of actually having your smart contract call the space and time network to run that query and get that answer in production is also pretty straightforward. You just save the query that you built in the sandbox, you save it. So now the chain gives you back a query ID. You embed that query ID into your smart contract, and you have your DeFi protocol smart contract send a small payment and the query ID to a space and time relayer contract, and what you get back next block is an already verified query result. All the complexity is abstracted away. You as a client contract, you pass in a query ID and a payment, and you get back an already verified query result via a callback method in Solidity. All the complexity of like what the chain does and how the provers operate, and like, the process of like oracling the query result plus the proof back to the chain to be verified, that's all abstracted away by relayer contracts that we deploy to make things really easy, an interface, you will. So in summary, while in dev, while building their queries, they get a nice AI studio to accelerate, and just like nobody wants to write SQL, let the AI write it for you. And then in production, just take the query you wrote with the AI partner in the sandbox and just embed that query ID in your smart contract, and next block you get back the result.
Yeah, thanks, Scott. I really like how streamlined that process is. Like you only need the only kind of real steps that the dev needs to do is like submitting that query ID and payment, and then they'll be able to get that verified query back. And then also you mentioned that these devs can also just ask natural language questions and then have these SQL queries just be generated for them, which I think is like really powerful in terms of going towards mainstream adoption. So really liked how streamlined that process is. I'm wondering if you could also, oh yeah, go ahead, Pavel.
I hate writing SQL queries, so anything that makes it
So do I.
easier is definitely
Or not have to do it at all, yeah.
Yeah, exactly. It's just not. It's a very powerful language that all the world's business runs on. Like every financial system in the world runs on SQL, but it's not fun language to write by any means. And I think like the best example of this on chain is probably eigenlayer AVS slashing. This is a fun example. Like if you wanted to build an oracle as an AVS, for example, how does an eigenlayer slashing contract know which oracle in the Oracle network messed up and should be slashed? Like that information would require a query. Like you could use space and time to kind of log all the Oracle jobs, when they were completed, which nodes participated in completing that job, which nodes voted during the quorum, which nodes joined the network and completed a job. And then you could just query space and time every hour, every day, heck, every block if you're willing to pay the gas, and just say, hey, for the last time period, show me all oracles that messed up, didn't complete a job, did complete jobs, how many jobs they completed, total payments they should receive, and it makes rewards and slashing of these restaked services so easy. And without a ZK coprocessor like space and time, there's really no efficient way to do this, because again, smart contracts on Solidity can't ask questions about things in the past. Like they can't say, hey, over the last hour, which Oracle payments got delivered or didn't get delivered? Which Oracle jobs got completed or didn't get completed? That's not something you can do without a ZK coprocessor. So space and time will, and other ZK coprocessors, like competitors of ours, will really open up that design space for restaked services.
Yeah, super exciting. And wondering if you could also go into some more detail about the developer journey, which you did previously mention. We were talking about how you guys were optimizing for the overall experience, but wondering if you could take us through like an end-to-end process for developer's journey with space and time. Like, for example, first connecting to the on-chain data and then running the query, publishing that query. So wondering if you could shed some light onto the process, like the step-by-step process in the developer's point of view.
I apologize. The step-by-step process for what exactly?
Just for the developer's experience. So first, when they're connecting to that on-chain data and then running a query, publishing that query. Just wondering if you could provide us with like an end-to-end process of what that looks like on the developer's perspective.
So step one is just exploring the data model. We just have like a really beautiful client web app that like lets you interactively explore all the data, like see all tables, their relationships, and just understand what our data model looks like. It's kind of a Dune style data model. You have a transaction, an Ethereum transactions table, an Ethereum blocks table, an Ethereum storage slot update table. And then you have a bunch of other tables that are specific to different protocols. Like there's a bunch of tables for Uniswap, a bunch of tables for Aave, a bunch of tables for Lido, for Eigenlayer, etc. And when I say tables for Lido, I mean tables that are just rows of data that capture every event emitted by the Lido smart contracts on chain, every event emitted by the Aave contracts. So then if you wanted to ask questions specifically about Aave, you could say, hey, show me, use the liquidations table and show me all liquidations greater than this value over the last month. And it's easier, it's just a better experience than trying to like sort out the entire Ethereum history of all transactions and write this crazy query that first finds the Lido transactions and then finds finds the Aave transactions and then finds liquidations, and then it's just a convenience, right? There's like the entire chain, and there's like tables that are specific to individual protocols to make it easier. So step one, find your data. Step two, ask the AI to write a query to answer the questions that you need to answer, right? I need to know all liquidations over the past month greater than $1 million. Write that. Natural language. Literally write the words, show me all Aave liquidations over the past month greater than $1 million, and watch what happens. Like, a query will get generated. It may not be perfect the first time, but it's something, it'll get you close. Sometimes it'll be right the first time, which I love. And that's a relatively complex question, and we have a relatively sophisticated AI engine to help. Okay, step two. You've got your data, you've got your query written. It's time to actually put that in production. You save that query in the space and time UI, which actually saves it on our network. Our network's now aware of that query ID and knows that, hey, soon there will be smart contracts that are going to ask us to run this query with ZK proofs. Then, step four, as I said earlier, embed that query ID in your DeFi protocol smart contract. Have your contract ask the space and time relayer contract to run this query ID with this little payment every block, every hour, every day, however you want to do it. You can use a keeper to ensure this happens every hour. You can have your own clients initiate transactions that then, when those get initiated, they call the space and time relayer. Like the example I gave earlier where Scott's taking out a loan, Scott's paying the gas to take out the loan. The lending protocol itself then queries Scott's wallet and asks space and time, hey, given Scott's wallet, show me the total volume of loans he's paid off. Like a one-time query that happens when I go to take out a loan, but they do this for every person that's taking out a loan. Step five is the space and time network sees that your contract has asked that question. We return back the query result and the proof. That gets verified on chain and then returned to your client contract, your DeFi protocol, as a callback in the next block. So it feels a lot like analogous to almost like how Chainlink works. And we were inspired by Chainlink immensely. I mean, Chainlink's an incredible project that is by far the most robust oracle in the market for delivering price feeds and other off-chain API requests. And the way they built Chainlink is exactly the same. Like, we were very inspired by their design of just like pass Chainlink a small payment and a request. The Chainlink network fulfills that request, and then you get your data back as a callback next block. That's it.
Yeah, nice, and really like that kind of 5-step process that's so like clear and very streamlined for developer on the other side. Like there really isn't too great of a learning curve that's involved for someone who just wants to like send and verify queries. Oh yeah, Pavel, go ahead.
One question on the process. So the user has to request the data essentially, and then that request is then fulfilled by space and time. Would there, and so that sounds a bit like a pull model. Is there a way to set up a automated or like within space and time, a way to have certain updates be posted when certain conditions are met? But I know you mentioned the keeper services, but I'm not sure if that's something that you might be looking into in the future to maybe have that integrated, or how what the thought process for that is.
Yeah. So I'm glad you brought this up because it's something I think about a lot, and we're finalizing a design for this right now. But short answer is twofold. One, you can use third-party oracles like keepers, like Chainlink keepers, to kind of continuously push data from space and like kind of have them continually ask space and time questions and push that to the chain, kind of continue periodically write data through the chain. We're also working on our own sort of forwarder or relayer that if you have a batch of things you want to do, like maybe once an hour, I want to query all the data from every single validator in my network, or if I'm an Oracle, or if I'm a bridge, like I want every hour to ask space and time for each bridge node operator in my network. What was their total rewards or total slashing I should do for each one? In that case, we're going to be giving back one query result, one table, one big answer that's columns like node operator ID or node operator public key, amount to be slashed, amount to be rewarded in one big table. But that's too much, way too much data for like Solidity to handle. You can't just dump that on chain. You can't just push that to the chain, right? You can't just push a 500 row query result to Ethereum. Like good luck. That'd be like 80 grand of gas. That'd cost like a Maserati worth of gas to put that on chain. So instead, you could use either like a Chainlink keeper or a relayer forwarder that we're building ourselves as a kind of a convenience in the space and time network that will then get that query result, and it'll initiate one transaction at a time to push this data for one node operator. Like the question that your smart contract wants to ask is, hey, for all the nodes in my network, give me a list of all nodes and how much to reward and slash over this epoch. Then we answer that question, and the forwarder rewards and slashes of each one at a time. Like push that to the chain. Like push a reward to the chain. Push a reward to the chain for this node operator, this node operator, this operator. And finally, like I think there's going to be a lot of need for continuous like data streams, like continuously push the price of Tesla stock on chain. And I think that market we leave to Chainlink. I think Chainlink has a good solution for that already. Like they already have a data streams that kind of pushes things to the chain in micro batches. And I'd say that's like a category where frankly you don't need space and time. If you're just pushing like one data point, like what's the current price of Tesla stock? What's the current price of Tesla stock? What's the current price of Tesla stock? You don't need a query engine. Chainlink's like the perfect solution for that. So that's like the third area where we'll just stay away from. The other two, space and time is a great solution for if you want to kind of push things to the chain in batch.
And I'm also wondering, just on the architecture side of the proof of SQL that you guys have incorporated within space and time, I'm wondering if you could speak a little bit about the kind of like the roles and interactions between the components that are present there, like with the prover, validator, consensus nodes as well, and also the interactions between like the prover and verifier for like submitting the data, then requesting the query, and then for the prover to generate a proof from it.
Yeah, so the verifier is a space and time deployed contract on the target chain. Like wherever the client is, that could be a client lending protocol on Avalanche, on Ethereum, on zk Era, whatever. We also deploy a space and time verifier contract. We call it a relayer because it's relaying the result. It's relaying the payment from the client to space and time, and it's relaying the result from space and time back to the client. But during the relaying back to the client, it actually verifies the ZK proof in Solidity on chain and pays gas to the target chain for doing so. What we've seen is that on Ethereum specifically, the gas costs for verifying these ZK proofs can be cumbersome. I mean, we're talking tens of dollars in egregious times when like gas is high. Maybe $100 in the worst case, like back in the like a few months ago when Ethereum gas was like $40 a transaction. I bet verifying a ZK proof at that time would have costed $100 of gas. Again, that's not normal. Normally it's like a few bucks, but even a few bucks is very cumbersome. And like what we're seeing is that specifically on Ethereum, not on fast, cheap chains like Era, but on Ethereum, I see like a future where verifier networks like Aligned Layer or Horizon or I know the ZK Sync Matter Labs team is working on something. We used Chainlink. Like we actually built a verifier using Chainlink functions where space and time returns the query result and proof to Chainlink. The Chainlink Dawn, the decentralized Oracle network, redundantly verifies our proof, trust minimized, using 30 Chainlink nodes. They redundant 30 nodes verify or approve off chain. They sign the verified query result and they relay it to the client so that the client only has to pay Chainlink gas and space and time gas, but not Ethereum gas. And like Chainlink's cheap, space and time's cheap. So like your total cost for that query might be 40 cents versus $4 on Ethereum. Using these like cheaper off-chain verifier networks as an oracle to sit between the space and time database and your client contract offers Ethereum devs a lower cost way to do off-chain verification that's trust minimized rather than fully trustless on Ethereum if they don't care about trustomized versus trustless. Like they just want to save on gas. That was a very long answer. I apologize, but the important thing to know is these proofs are mostly verified on chain. Most of our clients today are verifying on chain, and the space and time network is just returning back to the target chain the query result and the proof as a Solidity transaction, just like delivering the query result to the space and time relayer contract, which verifies the proof and returns the already verified query result next block to the client as a callback. Does that make sense?
Yeah, definitely. Yeah, thanks, Scott. And wondering also about some use cases and applications that are currently being built on space and time, and also ones that you're personally excited to see being developed. So what are some of the current use cases that are being built, and then also maybe some ones in the future that you'd like to see being built with space and time?
Yeah, I've got a lot of fun examples. There's a couple restaked kind of LST protocols and LRT protocols that are that want to run calculations periodically to see how much retail restakers, how much rewards they should get from the validators that they're staking against or the node operators they're staking against. It's one thing to slash and reward the nodes themselves for the jobs those nodes do. That is a great use case for space and time, and we're working with a couple like AVSs or symbiotic networks or Karak DSSs that want to do that. But separately, there's the actual LST and LRT protocols themselves that want to say, hey, over this 90-day epoch, for these 100 validators, how much of those validators' rewards should be split up between all the delegated restakers that stake money to them? That's an interesting use case that I never would have anticipated. That it's always exciting to see like customers doing things that you wouldn't have expected with space and time. And it's obvious in hindsight, like because there's no way to access that information easily in Solidity on chain. Again, kind of the theme of this discussion is, unfortunately, smart contracts can't ask these kinds of questions. So that's when you need a ZK coprocessor, and that's why they're looking to space and time to solve that. On the more fun, the more lighthearted side, there's a really cool game called Board AGI that's building on space and time, where the gaming server signs data and writes all the data to space and time, and then client contracts can query space and time to see what gamers did and reward them for in-game actions. There's a derivatives protocol called Diving Board that's one of the coolest like AI-powered crypto interface, like a consumer-facing crypto app that has a really cool AI-powered user experience to make buying derivatives and selling derivatives really, really easy. Kind of like turns the options market into a predictions market, where you just like tell a chatbot, hey, I bet that Bitcoin will be above 75,000 by the end of the month. And then it just does all the derivatives work for you behind the scenes and gives you a price and a bet. And they're using space and time to query all the information they need to calculate those derivatives prices and like price them correctly on chain. Because if you want to sell derivatives on Ethereum, like you generally are going to have some trusted, some centralized component in your architecture, unless you had space and time to give you all the implied volatilities, all the historical Ethereum and token prices you need to price this. And so their smart contracts are querying space and time to say, hey, what derivatives bets are settling today? What are the prices of those bets? What are the prices of the underlying assets? And did the better win or lose, and how much is their payout? Space and time becomes a source of truth for all of the bets, who placed them, when they should be rewarded, how much did they win, lose, and what is the implied volatility of all the different assets. Kind of building out a huge derivatives database for them. And these are just random examples, like these are just top of mind. But there's a lot of kind of larger marquee flagship DeFi customers that we're going after as well, like Lido, that we're really interested in working with in order to like expand the sophistication of their smart contracts, bring in this kind of more expressive, data-driven smart contract design to their smart contract developers. Aave and Lido have big teams that are like writing a lot of smart contracts, and we can open up the design space for them.
Yeah, really great to hear about like the huge kind of diversity in these kinds of examples, like from derivative protocols as you spoke about, and then also gaming as well. So really excited to see the really big diversity that's present here. I'm wondering, just as a last question before we close today's session, if you have any announcements you'd like to make for Space and Time, or if you have any kind of like last advice that you'd like to give to our audience.
Yeah, from an advice standpoint, if you're a builder, I'd say don't try to build everything yourself. That's a mistake that I made. Like, so much good infrastructure and so many good modular components have been pumped out over the last 3 years by well-funded, high-quality teams. So, like, I wouldn't have built my own indexer if I would have known the indexer market looks like in 2024. I wouldn't have started in 2021. In terms of like things that are exciting on the horizon, we are launching testnet next week. Or sorry, we things that are exciting on the horizon. We just launched testnet at SmartCon, and we're really excited to start onboarding validators to our testnet that we just launched. So if you are running a node and you want to participate, it's really easy to onboard. Follow Space and Time at Space and Time DB, or find us on Discord, and you can kind of join our node operator channel. And then finally, like, we're partnering up really heavily with ZK Sync, and we're really excited about the ZK Sync ecosystem because they're on the forefront of this. ZK is the end game. All ZK rollups will be, sorry, all rollups in general will someday be ZK verified, and like they're really ahead of the curve with a vision of what that looks like years from now, already building toward that vision. And like, given that Space and Time becomes much more valuable when there are a lot of L2s that have a lot of DeFi protocols asking a lot of cross-chain questions, like a DeFi protocol on Era asking questions about activity on Ethereum. That's where Space and Time becomes even more valuable. So we're partnering up real heavy with K-Sync to kind of be bring this like 40, 50 terabyte data set to the Ethereum, to the ZK Sync Elastic Chain ecosystem as well. So we're really excited about that.
Yeah, thanks, Scott. And really enjoyed overall to hear like first your journey from kind of developing these centralized to decentralized databases, and then your takes on the different cryptography related protocols in the space, ZK Endgame, and then also all the optimizations that you made with the developer experience for Space and Time. So really appreciate all your insights, and thank you so much again for joining us today.
It's been a blast. Thanks for having me on. Looking forward to talking more.
Yeah, thanks so much.
Awesome.